Yeah, so we are looking at designing scalable SaaS platforms for SMEs in emerging markets. Why cost efficient architecture wins in constrained markets? So why SME SaaS is fundamentally different? SME SaaS is not just a small SaaS, it's more like a SaaS that actually operates within a different physics and dynamics. So looking at this vital point when we talk about SMEs, that's the low average revenue per user. So typically SMEs, so because they are usually based on subscription, so it's usually between £5 to £10. So what that means is you have a low average revenue per user, and it has high probability to churn sensitivity. So what this means is when the rate of users that's unsubscribe from your packages, even when they are not that high, it affects your revenue significantly, in the sense that if you have 100 users and you have 5 users unsubscribing, that's more like a 5% loss that you have there in terms of your revenue. So it has low revenue per user. Then infrastructure stability, they're also prone to power outages in terms of physical. When you have a physical stores, power outages, you want to ensure you have strong powers, and also for weak broadbands. So most times the users might not even be in, those users that purchase probably through the softwares, they might not even be within reach of strong connectivity. So you need to also consider all those in your architecture. We also have device diversity. You want to ensure that your software is accessible even in devices that are obsolete in terms of their versioning. You want to optimize it to a very good standard. Also, the growth is not always linear, in the sense that you might just have spike of users within a certain period, maybe due to some festive or seasonal patterns that requires your app. You can just see easy sudden surge or spikes in activities, and then the cash flow volatility as well. So most users might not actually might not convert all users to all leads to actual in due time. Then SME is about survival, in the sense that you want to always checkmate that your revenues cost supersedes your running cost at all times. So we have big tech trap. So the most expensive mistakes that most tech companies make is trying to copy big architectures at the shell, where they want to replicate strong architectures like Netflix one or Google or those big industries already established. So you don't want to over-engineer your product before they hit the market, because you don't want to go above you don't want to have too much running cost to be able to maintain a product. So usually this table just shows the realistic comparison between startups and big tech, where you have for startups usually less than 10K users, and big startups 100 million above. Then also you have limited runway capital, while for startups and big tech have like abundant capital. Then in terms of the engineers, you have 1 to 5 within that range, and then for big tech, usually above 200. So architecture is a business decision, in the sense that whatever decision you make, it actually impacts your costs, and it also affects your customers' trust, because if customers um start seeing some anomalies in terms of the cost, maybe the cost spikes up, or due to some business decision, the customers start losing trust in your app, where maybe they need to do verification but it's failing, or they need to get the transaction done but it's not going through, or maybe you're adding more layers of abstraction or more layers of iteration just to cop security, but you're now putting more layers of abstraction. So all those things can actually change the customer's perception of your software. And also you want to ensure that the team complexity is not much, where they're able to undo tasks, and also make do of the business logic easily without having to have so much inconsistency in maintaining them. And then is a major decision factor where we talk about the monolith and microservice. Because usually most startups want to go microservice at the initial, and that's always kicks back at them, and it's always an issue. So usually you want to, for startups, you want to use monolith system, ensure that you have a core product, core single product, and then small engineering team where you can easily and rapidly bootstrap and try out different things. Then microservice architecture makes sense for big enterprises, and it's also because it's nice, but not okay for early startups because it's kind of increases the cost of production and running. So for microservice, it's good for big tech because it makes scaling independent, where you have different services performing different actions, and then when you have failovers, you can easily track those failovers to the particular point where it's been where the failure is coming from. The ownership mentality so you can have a certain team own certain services, and then you'd always need to reconcile on different mode of operation for those services. So this is just like a brief table here to juxtapose the two stages that requires the microservice architecture and monoliths. So at pre-production, you want to use the monolith modular one. At early growth, you want to use the structured monoliths. At a full scale, you want to go into the full-time microservice architecture. Then a typical pragmatic SaaS architecture would be something like this, where you have a stateless application layer. And what that means is you'd also want to do more of horizontal scaling without having to have too much dependencies to take care of. Then future-proof integrations, you want to ensure that your integrations are solid. That means writing test cases and also ensuring that they don't break over time. Then background jobs too. You want to queue your jobs because all this would also help reduce the cost of running. Because if you have all these jobs running, it prevents sudden spikes and sudden server overload, where you're able to queue services and they run at certain time and not overload the server costs. Then also you want to have a clear separation of concern, where once one particular controller or service does a particular thing and there's no mix of operations, what that means is they all run independently, but for a bigger cost. So you want to also have unit tests for all this, and then a comprehensive end-to-end test to be able to cover up all this, the worker, the data access, the controller and service too. Then observability early. You also want to keep track of your metrics, your cost tracking. You also have log systems so that you can easily debug issues. So even before your customers actually report issues to you, you can see those issues from your log and take care of them in due time, so as to give your customers better experience and journey. Then we have the multi-tenancy consideration. This is more like you trying to see how you can actually reduce costs to also while maintaining the standard. So you could consider three different approaches: either a shared database, which reduces costs. It reduces costs. It ensures that the database is nearer to the users itself. Then it reduces overhead as well, faster onboarding process because it does not have to eat different database to be able to perform that action. Then we have isolated tenants. This one is more like an higher cost, where you actually have tenants having their own instances, and this brings complexity in the cost in operation and maintaining the pricing too. But the better approach would be to have an hybrid approach where you have a shared core infrastructures. You also have an isolated clients for the premium ones, and then you're able to align the whole setup in terms of revenue. Performance other constraints. So this is very important because in SMEs, due to the large customer base, queries will be made, the site or the app is supposed to be very active. So you don't want to always you don't want all queries to always hit the database at every point in time. So you want to use infrastructure such as caching mechanism or queue-based processing, or you want to use an async email notification. So the caching is more like, okay, you can do statistics, or you can just go through your code base and you know the endpoints that are often queried, and you can add like a cache layer there where you use either Redis or any of these caching mechanisms to be able to keep the data for as long as they are not stale for revalidation. Then queuing processes, I mentioned this earlier. So you could use all these Bool MQ or all these processes to be able to prevent spikes. So let's say, for instance, you have sudden rush on your system. Instead of overloading the system, they all get queued to a particular process, and then they are processed in sequence or at convenience time. An async email too, you want to also prevent emails from blocking, because most times emails can take time to actually trigger. So you want to ensure that they are not blocking the operation. And this is also important in terms of rate limiting. You also want to prevent DOS attack. So what that means is when certain endpoint is being hit frequently, you can keep track of the IP or the person's location and block that request so as not to take down the availability of your app. Then cost versus scaling reality. So usually the cost usually grows linearly against the infrastructure. As you increase your infrastructure, it affects your cost too as well. But it becomes an issue when there's a sudden spike in the graph, where you just see the costs going up with a sudden shift in direction as opposed to what it was before. And then also when you scale database vertically instead of horizontally, it raises a concern when you have to actually add more instead of trying to expand the cloud-based instance. Then also, if you over reposition your compute, if you are using all these droplets or distribution or maybe GCP to deploy, and you have reprovised them and the cost overload on the system, it could also be an issue. So in summary, you want to ensure that there's no sudden spike in your costs per infrastructure costs. As you can see on this diagram, it should always be at least linear. We have what we call the unit economics, that's survival test. So in this context, you want to ensure that your lifetime value is always greater than or equal to 3 of your customer acquisition costs. That's the cost it takes you to acquire a particular customer, maybe due to from the adverts or the marketing, or also the infrastructure cost for that particular user. So you want to ensure that it is at least 3 times the cost of acquisition. Then if the cost of acquisition is above the lifetime value of the customer, that means like you are running towards a decline in terms of the customer's statistics. That means your scaling is actually impacting your cost of revenue. So this graph here just shows an LD1 where you have the cost per acquisition less than the lifetime value, and this is when the reverse is the case and requires reviewing your entire system architecture to be sure that everything is in good shape. So growth amplifies economies, whether good or bad. It affects the scalability ratio. And we have this part here that has to do with data-driven scaling. So in all you do, you want to use data to be able to make decision. You should not just make a decision without having insight on what is happening or what your system is actually talking about. So we have three sections here categorized under the customer intelligence, the growth optimization, then analytics, architecture. Customer intelligence is more, we have the cohorts retention tracking. So this is where you actually keep track of certain users that join your app at a certain period. And then after like a certain period, you want to also know how many of them have stopped using your system, how many have dropped. You want to keep that ratio because it helps you know if your system is actually improving or is declining with the retention ratio. So this might be the cost to life for a particular user. You want to consider the user's lifetime value when you're making your decision, your pricing decision. Okay, if this user is likely to stay for 10 years, what will be the best price to not be a burden to this user? You want to compare all those to come to a certain pricing decisions when you're making decision. Then life cycle analysis to reduce drop-offs too. You also want to check your metrics to know where you're having drop-offs in terms of the analysis, where the users are not actually getting the actual required resources they need to be able to execute their actions. Then this also is, you have to segment your efficient targeting. So this is more like you can do like all this Google analytics to know how your users are navigating your system, to know the pages they visit often, to also have like insights on what issues or blockers they're having. Then growth optimization, be able to ensure that you grow linearly or otherwise. You want to ensure like you do test pricing. You can first test a few prices and see the customer's reaction or see their level of interest to play around with what you'd eventually come up with also. And also you want to also experiment the onboarding experience of customers, maybe make it better or tweak the flow to be more shorter and more intuitive also. Statistical validation before scaling. Yeah, so you also need to decide at what point you need to maybe scale your infrastructures based on statistics too. Also, if you see that you're experiencing more downtime from statistics, you want to consider scaling up. Or if you see that customers are not actually getting the desired performance, you want to also increase your scaling, check your scaling metrics again. Then ML-based churn prediction. This is more like using machine learning to actually predict your customers' retention. So based on the past experience, you can actually run through machine learning to be able to determine, okay, at what point do I need to do better to be able to have a good and better customer retention. Analytics architecture, you want to have an event tracking design where you track users' activities. You can actually know what a user did and what was the experience of that particular user so that you can have a more personalized metrics. Central metrics layer, yeah, more like have a central point of view to view the users' activities, to view the subscription rates, everything that has to do with the customer's life cycle. Automated reports pipelines, yeah. So when necessary, you want to also set automated reports pipelines to help guide your decision. So instead of you going to actually view them, by default, the system creates those reports and sends them over to help better your architectural choices and decisions. Cost efficient data storage, yeah, data is actually important also. You want to ensure that your customers' data are safe and also while also considering the cost effectiveness of that. So the key lessons is architectures must match economic reality. Simplicity compounds over time. So even as you just have to keep everything simple, over time it starts to make sense. Over engineering is a killer, is a silent killer. So you don't want to over design and then kill the actual intent of the software. Cost predictability is survivor. Yeah, so based on the metrics we've talked about so far, the retention and the rest, you want to ensure that they are within that margin of survivor, which is usually between £550 subscription per month based on the SME packages. Then you scale deliberately, not emotionally. When you're scaling, you have to use statistics, you have to use your customer's experience, you have to check up before you make the final decision on whether to scale horizontally or vertically. Yeah, so emerging market they don't limit innovation. They just force engineers to actually be more disciplined in terms of making decisions, in terms of making choices that would go further to affect the users in the end. Yeah, these are can discuss about the trade-offs on all these architectures. Yeah, then thank you for your time, and yeah.